Hello everyone, in this video we are going to build a demo app that demonstrates the interrupt between Go and C Sharp. We will call Go functions from C Sharp and similarly C Sharp functions from Go. Before building the demo app, let's first understand why Go and C Sharp need to communicate, or in what kind of scenarios do we actually need this interrupt. Assume you have a C Sharp console app and you want to use a Go library, for example something like WebRTC. In that case, Go and C Sharp interrupt becomes necessary. Another scenario could be migration. You might want to rewrite your existing C Sharp code in Go or Go code in C Sharp. But such migration cannot complete in a single day, right? They usually happens gradually. Even during this transition period, we want our app to remain fully functional, right? So in these situations, interrupt helps both languages work together seamlessly. Before we dive in, let's understand the key technologies involved. On the Go side, we are going to use CGO. CGO is a built-in mechanism in Go that allows Go code to interact with C code. Similarly, on the C Sharp side, we will use pinvoke, which is a C Sharp's native interrupt mechanism. Using pinvoke, we can call functions that are exported from a DLL. In our case, pinvoke allows C Sharp to consume functions from Go generated DLL. So in short, to enable two-way communication between Go and C Sharp, we use CGO on the Go side and pinvoke on the C Sharp side. Now let's look at the prerequisites required to build this demo app. For Go, download and install the latest Go package from the official release page. And for CGO, we need GCC SE compiler. I will be using TDM GCC, so please download and install that as well. And to build the C Sharp console app, we need a .NET SDK. I will be using .NET SDK 8. Once the setup is complete, please verify the installation by running these commands. If any of these command throws an error, not found error, then please fix the issue before continuing with the video. One more thing, this is very, very important. Once setup is done, please make sure all installed tools are added to your system's path environment variable. Now let's look at the folder structure. I have created a root folder called Go C Sharp Interrupt. Inside that, I have created two separate folders, one for Go library and one for C Sharp application. And inside C Sharp app folder, I have already created a .NET SDK console project. Now let's move on to building the Go library. First, we need to initialize Go module. Let me go inside Go lib folder and I'm going to initialize module, Go module. Let's say Go C Sharp interrupt. Okay, module is initialized and we can see the go.mod file here. Now let's create a main.go file. Right. Now let's create a package main. This is required when building exe or shared library in Go. Now I'm going to import C. This is to enable C Go so that Go can interact with C code. Now I'm going to write a function to add two numbers. Function add and it will return the result. And just above the function, I have added a command saying // export add. Actually, this export tells C go to export this add function. So this export command is needed. Finally, I'm going to define main function. Main function is record, but it can remain empty because we are going to develop a Go library, not a standalone application. Yeah, that's it. Our function is ready. Now let's build the Go module. For that, first we need to enable CGO. Done. Now I'm going to statically link C runtime to avoid external dependencies issue. Now we can proceed with a Go build. So here you can see build mode equal to C sharp. That means we are telling Go to generate the DLL, and then we are passing -s -w linker flags. This is to remove debug information to reduce DLL size. And we need to specify the output path here. And finally, we have a dot. It tells Go to build the package in the current directory. Let me copy the command. Okay. After running this command, two files will be generated here. Yeah, one is a .dll file. It's a shared library, and another is a .h file. This is a header file. Contains exported add function. You can see here. So now that our Go library is ready, now we can create a C# console app. Okay. Here our goal is to call exported add functions using pinvoke, right? So for that, I'm going to create a separate utility class here. Add new item. Let's say goal lib. Okay, the file is created. Now we need to declare the function. The function name is add. Okay, let me also, it's the same. You can say public. And one more thing, we need to declare a function as extend function. So public static extend. Return type is int. Function name is add. And it takes two argument of type integer. So the function declaration should match the signature of exported add function. But here it is going. Let me change that to saint. Okay, let me rebuild it. Okay. Now let's check the signature here. Yeah, it's changed to integer. Here also we are having integer. Now let's add the DLL import attribute. Okay, what's the name of the DLL? Golib. Mm, we also need to specify the calling convention here. By default, C Go exports functions using C declaration. So we must also use the same here. Okay. Now the function is imported here. Now let's try calling this from main method. Lib dot add. Let's pass 2 comma 3 and it will return a result, right? Let's store that in a variable called sum. Now let's print the value as well. Let's say is addition. Okay, so that's it. Now let's build C sharp app. Okay, done. Now we can run the app. Debug now. Okay, here is the app. Let's open it in a command prompt. Oops, we are getting your DLL not found exception. This is because we forgot to copy the Go DLL into the C sharp output directory. Let's do that. This one. Let me copy this and paste it inside .NET folder. Okay. Now let's run it again. Awesome, it works. So far we have seen how to call a Go functions from C sharp, right? Now let's take a look at the reverse. How to call C sharp function from Go. For that, first we need to write a callback function, or else let me write down the steps first. Um, First, need to write a callback function, and then on this Go side, we need to define a function pointer for the callback. Function pointer. Then we need to have a setter for callback. So we can say expose setter for callback. And then again, we need to expose an API to trigger this call. We can say expose an API to trigger callback. This is what we are going to do. So first, write a callback function in C sharp. I'm writing a multiplication function here. Static will return integer value. The function it can be multiply, and it takes two argument in A and B, and it will return the result. Okay, now callback is ready. And what's the next step? We need to define a function pointer for the callback. So I'm going to main.go. Here we can have a function pointer. So I'm creating a command section. So in C Go, all C code should be written inside the command section just above imports. Now let's define a function pointer. The return type is integer, and we can say callback, and it takes in two arguments of type integer. And in C Go, we cannot call a function pointer directly. We need to have a function to invoke it. So let me write that as well. Static int. We are just going to invoke it. So let's say void invoke callback. Done. Now we need to have a return value from C sharp, right? Let's return it. Done. Okay. Now, okay, invoke is ready. What's the next step? Now we need to expose setter. Okay, let's write a setter function. Function set callback. Okay. We need to take callback function pointer as an argument. So for that purpose, I'm going to create a variable of type callback. Uh, okay, set callback. It takes a function pointer and store it in a local variable. Similarly, we need to expose an API to trigger callback. Let's write that. Function trigger callback. Okay, done. So trigger callback has two params, and if callback is not null, then it will invoke the C helper function. C helper function will invoke a function pointer. This is nothing but a C sharp callback function. So Go code is ready. We are almost done. We just need to call these newly exported functions from Go C sharp side. Let's go to C sharp. Go lib data. This one. It's the first method. Set callback. It takes a function pointer. So in C sharp, we need to define a delegate for this. Public delegate setter, right? So the return type is void. Function name, let's say multiply delegate. Okay, and we need to pass to integer values. So actually we are creating delegate for a function pointer. So if it has return value int, then we should also return integer value from here. Now let's add a function pointer attribute here. Same calling convention, that is C declaration. And now let's let's declare set callback function in C sharp. Public static extend return type is void, and we need to have the same function name. Let me copy this. And we need to pass the delegate. Now let's do the same DLL import and also the calling convention. Similarly, we need to declare a function in the function for trigger callback. So for every exported Go function, we must declare a corresponding function in C sharp. Trigger callback. Okay, let me just copy paste. Trigger callback text to argument int a and int b. and it returns a value. Yeah, it returns integer. Alright, now we just need to call these functions from main method. So first we need to set the callback. So set callback and I'm passing multiply function to it. Then we can trigger the callback. Passing 2, comma 3. Let's store the result in a variable say result and print the value. Console write line. Say multiplication and result. Done. Okay, let's build the Go library first. Missing return. Go main.go line number 28. Okay, let's return a value -1 and let's build it again. Again, missing return at line number 28. Let me create a new console. cd go lib. Hmm. Okay, no errors and the DLL is updated. Now let's copy this DLL to C# output directory. Sorry, this the 120.156, 2156. Copy this. Paste it here. Now let's build the C# app as well. Rebuild. Okay, now we can run the app. Yeah, so as you can see here, addition is correct and multiplication also correct. So the overall flow will be C# is passing the callback to Go using set callback function. Go stores it in a variable, and when trigger callback is triggered from C#, it invokes C helper function. C helper function internally calls callback. It's nothing but a multiply function from C#. So we have achieved the two-way communication between Go and C#. Like I mentioned earlier, this is just a simple demo app, but you can use this as a template for your larger integration. Um, you can add, you can export more functions here, and you can pass more complex data types, and you can register multiple callbacks. Just scale this architecture based on your project requirements, but please follow the same interrupt pattern we implemented here. Yeah, that's all for this video. I really hope this video was useful to you. Thanks for watching.